Bhushan from School of Computer Science, and I will be talking about today Java security. And this is related to CSM05 or BIT 5th trimester course now. So in fact I will be talking in these few steps. First I will talk about, look at this slide, first I will talk about why Java is safer than other programming languages. Then I will talk about certain other concepts related to Java security called loading, linking, initializations, and finally I will be talking about the security manager policy and permissions issues now. Java security is one such feature of Java programming language. Java programming comes with large number of features, and security is one of the prime issue in the Java programming language. In fact, security is the major hot topic today in the computer science areas. Because today we are talking about, because the internet has become the major delivery schemes, delivery mechanism in the software industry. So through internet we try to collaborate, try to distribute the code. So earlier the computer was confined to a single machine. We were working, our activities were confined to a single machine. Today we have every computer is coming with the modem, every computer is connected with the network card. So today our system is connected with all other systems outside the world. So we are trying to connect all these systems together. That is why the code has to be distributed accordingly. And then security is the main issue now. So now, before coming to the Java security as issue in Java programming language, let me talk about some other important issues in Java programming language which are very much important for you to understand. Java program is independent of any platforms, independent of any microprocessors, independent of any operating systems environment. So this is third important feature. First, let me just give you in detail the important features of Java programming language, and Java security is one of the important features of it. The fourth one is Java is a highly distributed programming language. This one I had explained in the beginning, that today the whole machine is a part of the network. So that Java was designed to exploit this type of configuration. They know that the program, the system are part of the network, so there has to be a software which control the whole network system. Today the whole software is also being designed in a network environment. You see the Oracle 9i or other programming language, they are network enabled now. And security, now coming back to, so like Java has many other important many programming features now. In fact, one of the most important among all of them is Java is a multimedia programming language. It supports lots of multimedia features. It supports audio, it supports video, and all other features now. Coming back to this security feature, which is the main topic for our discussion, let me just talk about what is the security issues in fact, we will talk about network security rather than operating system security. By network security, you must understand that there is a process called client process, there is a process called server process. So for example, whenever a sender sends any data to the receiver, the passes through a network. So for example, between the sender and the receiver there is a network, there is an internet. Now your data passes through this internet, and then in this process it passes through number of other stages where the system or program can be hacked, or someone else can spoof your program, and so on and so forth. So Java has to take care of all this. The system has been designed in such a way that the program can be easily distributed, and internet becomes the main engine for distribution of the code now. So first we will talk about why Java is safer than other programming language, because safety is important issues now. And security, as I told you in the beginning, is very hot topic, and lots of issues are there. Cryptography, another important discipline in the computer science area. So let me first talk about why Java is safer than this one now. I told you that Java is a very simple compared to C++, an object-oriented programming language. Again, C++ is also object-oriented programming language, but it's simpler than C++. Java is a robust language developed at Sun Microsystem. Now Java is, compared to other programming languages, highly robust. It has exception handling features now. So if something goes wrong, Java gives you a proper warning. You can easily skip with crash of your program, which other programming language did not support. So we say that Java is a robust programming language. The one thing which you must understand, the important point which you have to understand, these are the features, and then what are the important packages through which you get those features now. For example, to get robustness in your program, you have to use exception handling features. In fact, C++ also provides you exception handling feature. Java inherited exception handling or robustness characteristics from C++, but C++ didn't impose these characteristics on the programmers now. So the programmers were free, they wanted to use this feature, or if they don't want, there were no binding on the programmer to include any robustness characters in the programming feature. But in Java imposes this one. If you don't use exception handling feature in the program, then Java gives you a proper warning. So that way Java is highly robust than any other programming language. Java compiler generates class files which have architecturally neutral binary intermediate format. This is very much important point for you to understand. And that is from here we will start how the security features have been built into a Java programming language. So for example, as I told you earlier, that Java compiler produces the code specific to that platforms. I mean, most of the programming language produces the code specific to that platform, whereas a Java programming language is independent of it. They don't consider what type of microprocessor is sitting, what is the size of a registers, right? So they simply produce a code which is independent of the platforms, and what they call it a byte code. It's called intermediate format now. So this is what the Java is. So Java has many features, and the code produced by Java is independent of any platforms. Now the point which you have to understand is, I told you earlier, that Java produces the class file, and the class file creates a byte code, or sometimes in the literature you will find that Java simply produces the byte code. Now here is the point now which you have to understand. This is, just look at this slide, this most important message I want to just convey to you, that embedded in the class file are the byte codes, which are implementation for each of the class methods written in the instruction set of a virtual machine. Now here is the concept of a virtual machine is very much important once again. When we talk of other programming languages and the compiler, they are virtual, they don't talk about any virtual machine as such. They simply talk about the microprocessor which is sitting inside the machine. So if microprocessors has got 16-bit register, they will simply convert your code into 16-bit registers. If they have a 6 register, they will simply talk about in 6 registers and so on. So they simply talk about in the language which microprocessor of that machine understand. But in Java simply talks about a virtual machines. Means they talk about although your registers might be supporting only 16-bit, but Java code might be producing you they might talk to the register which of 32-bit, which is not existing there. So we say that Java is a basically virtual machine. Java talks about in a virtual machine rather than in any physical machine. But finally, the point which you have to understand is when you want to run this program on any platform, it has to be converted. So that is the runtime affair, not the compile time affair. But in normally programming language, the compile time also talks about in the language which is specific to that machine. Here what we are talking about, that the compile time is also free of all the platforms which you have on your machine. That is a major gain we have achieved now. So you run your program, you can download a program written by someone else and running on your systems. You are not aware of at what platforms he has written, in what architecture this program has been developed, who has developed this platform. So you must be very, so it is possible only when the compiler produces the code independent of that platforms. So now here is the point is that the byte code is independent. In other programming language, we don't call this term as a byte code. We simply say machine code. But here we are talking about byte code just to indicate that the code is independent of any platforms now. But byte code has to be run by that particular systems now. For example, any byte code I can receive from anywhere else, but I must have a system which will finally convert them into the code which my machine understands. So that has to be done finally, because finally the machine has to be run on particular system, particular environment. But 60-70% work which has been done by the compiler is independent of any platform. Only 30%, 40% work which you have to do, that has to be specific to particular type of configuration, and that will be done by the runtime system. So for example, you know basics of Java programming language, that basic understanding you must have for today's discussion, that anyone can write a program or anyone can download a program or call applet. In Java, the two types of applications we talk about. One is application and second is called applet. So I can write my program convert them into form of applet, or I can write an applet and I can send it anywhere else and someone can run this program on their machine, or I can download an applet written by someone else and run my system. But Java browser must convert them into the environment on which browser has been loaded now. That is the point which we are talking about. So the bytecodes are executed by means of a runtime system. That is very important. And what is the runtime system? The runtime system is a part of your browsers now. In fact, Java became popular because of those browsers now. Had the browser not supported the Java system, then your Java couldn't have become such a popular now. So browser works just like an interface, or just like a front end tool for the systems now. So you download your program and Java browser runs them on their machines now, and it is job of the Java browser or runtime system to convert them the code specific to that platforms now. So Java works just like an emulator for the virtual machines. The same bytecodes can be run on any platform. Already I explained to you. Now here is I can support Java security. So the security now I have been explaining with these terms quite often, because that is the point which you have to understand very well. Security is not issue in other programming language. Security is the issue in the Java programming language. In fact, this is the issue in the Java programming language, because Java has been designed to handle a very large system, not confined to only one system. Although when we write a program in other programming language, I can handle them. I can write a very large program, but Java is specifically basically designed for that purpose only. Java assumes that there are large number of systems scattered all over the world, and internet will be a tool for connecting all those machines. So there must be a certain tool, environment, platform, software which will able to connect all the people are working on a similar project, although they might be scattered in distance. So now Java handles these security problems at different levels now. So we'll talk about first low level security, and that is most important part of our discussions now. And here you have to understand, always you have to compare with C++ now. In fact, C language now. Now here is the security through this is second point is more important. Security through lack of pointers arithmetic. Now this is what we are talking about is. In fact, first one said that everything very well defined, but the second is more important now, is that in C language you have a pointers arithmetic now. For example, I can do address manipulations now. For example, if I have to find out the length of a string, for example, I have written, let's say, A, B, C, D, E, F, G. This is my string now. Just recall your C language now, at least features of C language. So this is my string A, B, C, D, E, F, G. Now if I ask you to write a program to find out the length of a string, then you can call some of the library function, or if you have to simulate yourself. One way to do is, I'm just simply explaining what is the meaning of a pointer arithmetic, is that you can create two pointers. One pointer will point to the beginning of the character, another pointer will point to the end of the character, right? And then simply subtract these two pointers, you will find the length of a string. And this is called pointers arithmetic, where you are subtracting two pointers. Pointer is a variable which points to a locations where one variable or some variable are stored now. So this is what we'll call them. You are controlling the addresses, and that is basically creating a security violations from Java point of view. In Java programming language, you don't have a control at the low level. You cannot manipulate pointers. You cannot do any arithmetic manipulation on those pointers now. It is the first important level of check at low level through Java programming language, which other programming language does not give you that type of support now. Security through garbage collection. But anyway, just explain you the term is called what we call them garbage collections now. The there is a program called garbage collector, which keeps on running behind the scene. This is a part of your Java browser, or it is part of your operating system. So what is the job of the Java garbage collection is that they keep on scanning those variables which are occupying certain memory location but not being accessed by the program for quite some time. So now they try to remove these variables or these pages and get those buffers free of those variables so that you can have a larger memory at your disposal. Now here also could be a security violations which Java does not allow you to do this one, where other programming language you can do some tampering. Now a strict type checking, this is another important component to provide the security. Now what we have to do, what we do in programming language, let's say C language. In C language you can declare a variable of character type, you can declare a variable of float data type, you can declare a variable of integer data type, and you can try to add all these variables, and then finally it will be automatically converted to the largest data type. Let me explain this concept once again. From security point of view, this is not a correct. C programming language supports, even C++ does not have a check, and these all are being done by the programmer unintentionally to do anything, but they without it you cannot write a program. That happens, that is part of the syntax support by the C++, but finally inside it can create a security problems. Now let me explain these examples once again to understand this point. Java, you can mix all different data types. Like for example, if I have to add 2-3 numbers, you can declare one number to be integer data type, another number to be float data type, third number you can declare as a double type, and finally system C compiler will automatically convert them into the largest data type, that is a double. So that type of mixing takes place in C++, which is not possible in Java programming language. So Java provides you this type of things also. So the three features which I told you, that Java controls through pointers arithmetic, security is controlled in Java through pointers, controlled through a garbage collection, third is through a strict type checking, and the fourth one is called access control using a specifier that are enforced at a linking time. We'll explain you about linking, loading at a later stage. That also is being one of the important security violations in other programming language which we don't find in Java programming now. Now the another time, now so the first part is over now. We are talking about 3 or 4 levels. First was the security support at low level in Java. Let me go to talk about some other features where through which we control security features in Java. It's called class loading now. Now loading word, you know that normally, of course there might be some distinctions between the concept which I am trying to explain right now, but to grasp this idea, normally in other conventional programming language we come along with this type of concept, linker and loader and so on. Now what is a linker and loader? You must understand, the C compiler or any other programming language compiler does not produce the code in the exe form, in executable form, right? So for example, if you compile C language program, they don't produce the code and you can immediately start running the program. You require some linkers, you require certain loaders. So linker and loader, these are the software models. They are the system software model which makes your program in the exe form or in the executable form. Unless your program is loaded into the RAM area, your program is not going to stay. Unless your program gets a control from the CPU, your program is not getting executed. By simply converting your program into the machine language which is being done by the compiler, your program is still not ready to be run by the CPU. Your program has to be stored first into the memory locations. In program, wherever you have made a reference to a library or to any other utility, all these utilities must be linked with your program. Suppose that you have passed a reference to some other program, you have made a reference to some library function. C compiler does not convert them into machine language immediately. Finally, or C compiler does not give the specific locations where all these codes are going to be stored. Your program must be very, very high. Let's say for example, you can write a program bigger than the size of your RAM area. Your RAM might be some kbytes or the megabytes, but your program could be much more larger than the gigabytes. So your program will not start immediately running. The program has to be packed into the main memory first. Compiler is not aware of the memory mapping at all. It is job of the linkers and loader which will able to map particular fragments of the program into certain memory locations now. So the purpose of the linker loader generally means making your program in the exe form so the system start running now. Here we have a very similar concept to understand. We say class loading, class verifier, and so on. So let's come back to this slide once again, giving you certain background about linking and loading. What loading we understand, what do we understand by loading in Java terminology? Loading refers to the process of finding the binary form of a class or interface with a particular name. For example, I told you that Java produces the bytecode. Java produces a byte class files, and these class files contains those bytecodes now. So loading basically refers to the process of finding these binary forms of the class and try to resolve the interface with. Now Java virtual machines, I told you that basically the bytecode or the Java compiler basically produce a code that simply understand the virtual machine. They don't talk about any specific machine as such. So JVM stands for Java Virtual Machine, defines a default class loader called the bootstrap class loader. Now there is also a loader, we say loader and linker. In Java terminology we say it is class loader because Java compiler produces the class file. This class which contains the bytecode has to be loaded into memory, and this is being done by the class loaders now. So class loader is a called module in the Java systems, which purpose is to load the class file produced by Java compiler. This class loader, but during this process also they do lots of security checks. In other programming language we don't do. When we say linker and loader, their job they don't address the security issues, but it is the class loader and in the Java which does a very responsible work whereas the security issue is concerned. Now this class loader defines the basic security setup now, which it handles. Now what they do is this applications can override this by creating a subclass of class loader class and defining more specific security policies now. So what I'm talking about is the class loader is a module in Java programming language whose job is not simply to load the class files which has been created by the compiler, but while loading these class files they do lots of security checks whether the programmer has violated something else or not. This is what the message which we are trying to convey now. Now here is they will not go into these details now how the class loader is basically how it is defined. It is normally you have to understand in terms of the Java syntax. In terms of here I am creating certain loader objects. By this you look at the first statement, class loader equals new network class dot load. This is basically how the class loader really works and what are those syntax are being followed while loading the class one now. Now here is the just try to understand the point which was explained through 3 statements in the previous slides, the steps which takes place during the class loading. But let me remind you once again, the purpose of the loading is not simply loading as such what we do in normal conventional programming language, but loading in such a way that all the class files have been no security violations has taken place into all those class files produced by the compilers now. Now here you just assume that just name 2 classes. Let's say for example steps used to derive the class C. Let's say class C is one such class in the class file, and loader is a class loader which loads this class file. So using loader L from a representations in class the file format R, first what we do is, what I'm trying to explain to you is that suppose the class file called C which is being loaded by class loader L. Now what are the steps follows now? First step number 1, look at this slide now once again. The Java virtual machine determines whether it has already recorded that L is an initiating loader of a class C, number 1, and then it transforms the name into a file name and then read the class file of that name from a file system. So this is the steps required because no one, like say for example if you say Java has a all these main packages defined by Java, it starts with Java dot this one, Java dot this one. So they basically check that whether the names are proper valid names or not. And then here is this phase of loading must detect the following errors. Now what they do is just to have again that security violations have not taken place. If the representation is not in a class file form, then loading throws an instance of class forms error. This is again the checking is there, that if the format of the class file has been not be fully defined, then it will create an error. Remember the first or second slide I was talking about that Java is a robust programming language. The purpose of robustness of Java is that it will throw an error if there's something has gone wrong into, so that there will be no abruptions in the program, but simply you can easily escape through, prepare to fly a program once again, and then again come back to it. This is called robustness of this. So Java defines exception handling feature through which you can write a good Java, more what we call them robust program now. So they provided lots of other features now. So this, if the representation is not in the class file form, then it throws you this error. Otherwise, if the representation, just to check to whether the class file defined by the class Java compiler is properly defined or not, if the representation is not of a supported version, like Java dot this one, Java dot this one, and so on, and all the classes are well defined classes. So purpose here is if the class name does not follow the predefined convention, the class loader will create an error that this class, just to give a warning that all these classes created by a Java compiler are basically have not passed through security checks. Now this is the basic idea. So they passes through a number of different messages and keeps on creating lots of errors for that purpose. Now if the class C has any super class, they are recursively loaded and linked during this step. Here simply I will explain you the term called a recursion. Recursion is a very important programming concepts now, and most of the programming language supports the recursion feature. C language supports the recursion feature. Java supports the recursion feature. Most of the programming languages today support the recursion feature, and this is a very important tool in the computer science. You can solve lots of problems through recursions now, for example, and there are certain problems are recursively defined. By one small definition of a recursion, something is defined through itself. For example, let's just take example of a factorial problem. A factorial problem says that if I have to find a factorial of a particular number, let's say factorial of n. Now factorial of n is defined through n multiplied by n minus 1 factorial. So if something is defined through itself, we say it is a factorial. It is a recursive problem. So one can solve it just in a straightforward manner if the language provides you recursive feature. Take another example of a Fibonacci series. Suppose that I have to find out the Fibonacci of one number, then I have to find the Fibonacci of its previous number, and then add its value. So this is where we say recursions now. And in data structure, once you go to 8th trimester, we do lots of data structure course topics. There again the recursion topic will be coming. So lots of dynamic data structures are defined through recursion. Now once we have finished now the class loader, again I told you the class load, again I am reminding you the class loader is one such module which makes a class files, which makes a program in the running state, and also try to check whether the security violation has been done or not. Now linking is again the process of taking a binary form of a class file and combining it into the runtime state of Java virtual machine. Now again what we have defined you, the linking is normally the meaning of a linking means, for example, I have written a program and I have made a reference to certain libraries which you in other libraries. For example, if you write a program in C language, there are lots of header files are there, and now suppose that you are working a particular header file and now you are making a reference to another header file, right? Or if someone written a program, you are making a reference to that program. The purpose of linking is to link your program with those references, and this process they also try to check the security violations. Now two different activities takes place involved in the linking process, again for security purpose now. And right now we are talking about the low level security. One is called verifications and the second is resolution of the symbolic references. Now why verifications? Why we required verify? This term is basically you must be aware of verifications, validations, testing. These terms you might be aware of CSI 02 when you did your system analysis of your work. and before, I mean, you have to do this one. These are the important states of your program. Then only you can say that your program is not going to crash, or your program will work in all these situations now. So verifications, validation, testing, you might be aware otherwise from other disciplines now. Now here the verification has a different meaning, but again the purpose is to make your program much more secure now. Now here is the, let me just come back to the slide now. The Java virtual machine, basically your runtime module, has no guarantee that any file it is asked to load was generated by some compiler or is properly formed. Now basically they are not aware of, suppose that you are asking the system to load certain file, whether this file has been properly created or not, it contains the proper specifications or not, it is not, basically Java systems are not aware of. So you have to provide those informations to them. So purpose of the verification to see that everything goes very well. A browser downloads, so when I want to download any program, what browser does? Simply downloads already compiled class files. For example, what I was talking about is applet concept of applet I was talking to. That in Java you can do two things. One, you can write an application which you can run on your machine, or I can download certain program written by someone else which is in the form of a applet and run it at my own systems now. So there is a Java browser is there which makes this program, it has a class loader, it has a linking module, and makes your programs run on your system, although it was written by someone else, written into different platforms, different operating system, different microprocessor, but the code which you download, it has basically in the compiled class files now. Now it is job of the browser to make them, load them and run your program, and also check whether security violations has been checked, whether the program has created certain security violations or not. So now what they do is, so they are class files, right? They are not in the running state. It is the job of browser to make it runnable state now. So now why, I'm just trying to explain you why verification concept is required. So if I want to download any program, what browser will do? Simply you click that applet and browser will try to download this one, and these programs are basically in the compiled class files. Now why the browser, let me this slide now. I'm trying to answer the question which I raised earlier, why verification? The browser needs to determine whether the class file was produced by a trustworthy compiler or by an adversary attempting to exploit the virtual machine. So one has to check now. Now these are the issues which are not required the conventional system, because you know that who has written this program. You basically don't work in the network environment, but if you are working in a network environment and you are connected through the internet, you can download any file. You must verify whether this file which you have downloaded are correct or not, whether it will create certain problem for your machine or not, whether it carries some virus or not, and so on. So the job of verification is related to this type of activities. Now these activities are part of the browser. Browser basically does all these activities internally. So what they do basically, I answered the question what, why, now we're answering the question how it happens. The representation of a class or interface is verified to ensure that its binary representation is structurally valid. Internally it is well structured. Linking time verifications enhances the performance of an interpreter. So these all are, sometimes there is lots of debate is going on because Java has a different objectives, but because of this one, it's just like what we do a study in the computer network, that TCP/IP is a very, very highly reliable protocol that we know as a part of computer network. It's a highly reliable protocol. But to achieve the reliability, what it does is that each packet has to be sequenced, each packet has to be acknowledged. So for this purpose, you have to waste lots of time. Bandwidth will be utilized for this purpose, because unless you get the acknowledgement of the packet, you will not send the next packet, for example. Or you must check at each hop that whether the packet which is being carried over does not contain any error or not, just for the sake of reliability issues. So just for verifications and all these processes, security issues, Java programs are a bit slower, and that is the people say this is the drawback of the Java programming language. But you see with these latest releases and the announcement and the work going on in Java side, that the programming become much more faster day by day. So now, with just giving you some background about the verifications, what is verification, why verification, let me just create little bit more, much more detailed what exactly I told you earlier. Let me try to explain the whole process of verifications. We try to divide into 2 steps. Let me start with the pass 1, and this is called pass 1, pass 2, and so on. Now each file has certain basic formats. Just like what we do now is that each packet has a certain format. For example, if you send your data through Ethernet, right? Ethernet is your basic LAN card. Now here sitting in your systems now, one of the technology for creating a local area network. Now Ethernet has certain structure for the packet now. That first few bits will be of this one, the last few bits will be of this purpose, the few middle bits will be meant for this purpose now. So if someone creates a wrong, then system must be able to identify that this is not a proper packet. So the pass 1 of verification process which takes place during the linking is related to whether the file has a basic format of a class file or not. Each one must have. So if you try to represent your class into the binary, they must give certain structure. Like for example, I mean, if you are not still not getting through what we are talking about, is that you know that if each operating system has certain structure to store the file. Someone might be creating byte by byte, someone might be creating a record by record. At the end of each record, they must have some terminator key. Okay, this is one record is over, the second record starts, the third record is over, fourth record starts. So they have a certain format to represent the file. Similarly, the Java checks whether the class file created by compiler is a done by the trustworthy compiler or not. So it checks the basic format. All recognized attributes must be having a proper length. As I told you in the packet size also, we know that for the error checking bit called CRC must have few many bits. For data bits should not exceed more than that. So each bit has a predefined length. Again, if the length is violated, again might be security violation has taken place. The class file must not be truncated or have extra bytes at the end. Means if I am talking about 20 bytes of a class file, it must have just 20 bytes, not more than that, not less than that. If it is more than, then means that extra byte is created, which might create a harm to the system. So the purpose of the verifications, let me repeat once again, to check the format of the file is properly defined or not, length has been properly defined or not, if no bit has been truncated or not. So these are the things which we consider as a part of verification process. This is done at the internal level. It is done by the class loader, by class verifier. Where it is done by the inside the browser itself. So before you start running your program, system checks everything that security violations has not taken place now. And of course, during this process, it gets delayed, but the basic purpose remains the same, that support this system or software for distributed environment, which Java has already achieved now. Ensures that the final classes are not subclassed and that final methods are not overridden. These are the modifiers that you must know from basic Java programming language. Final is one modifier, abstract is another modifier, and each one has certain meanings. Right, a static has another modifier. You know that lots of modifiers are there in a Java programming language. The abstract, the what we'll say, and some are the method modifiers, some are the class modifier. Let's say for example, public, private, protected. These are the basically tells you whether you can access certain method of a class or not. And then we have a abstract. Then we have a final. So now we say that if you have defined certain class as a final, then it is a final. No other class can modify this class. So now during the verification, it checks whether the class which is written with the modifier tag has been modified by someone else or not. If it has been modified or it has been overridden by someone else, it means certain security violation has taken place in this one. And this is all done by the verifications. So linking, just like normally also we do the linking in number of stages. So here also we are doing linking in 2-3 passes because the number of steps are very, very large. Just like what we do is a normal practice in the software design, that if a software is a very complex process, then we design into number of stages now. For example, computer network, we define through number of different stages. Applications layer is one such a stage. The Physical layer is another such a stage, and each stage we define certain functionality. The checks that every class has a direct superclass, checking that all field references. See here in Java, the point is it basically defines the proper architecture of a Java programming language. When you write a Java programming language, that the basic understanding must be there, and same thing we are trying to test it through class modifier or class linkers now. So every class must have some superclass. They must have a certain they are somehow very tightly coupled. When you write a program in Java, the basic structure should be that there must be some base class, and then you derive a number of subclasses. You can derive number of subclasses of particular subclass. So you have to create certain inheritance type of tree. Now this is the basic structure of your programs. When you write a program in C language, basic structure is to define a main function, and through main function you can call large number of functions. So that way you define, that is basic structure of the C programming language. In Java, if you see the Java technology, Java architecture, there is just some class, there is certain object, and all the classes and other objects have been derived from this object, and that is called base object. That has to be there. If this one is corrupted, then nothing you will be able to access to it. That way the whole structure has been defined. Nothing has been put into only one class and so on. Each class is a smaller class and a part of some other classes. So this is subclasses. So each class has got superclasses, each class has got subclasses now. So here we say from the security point of view, that way the system has been designed, and that checks that every class except object. I was referring to this point. Object is the parent of all the classes now. It is defined into one of the classes now, which automatically loaded with your program. Certain package which you have to do. For example, if I want to do networking applications in Java, I have to specifically import java.net. If I play with multimedia around, then I have to load the java.awt package. But there is a class, there is a file, there is a utility, there is a package called which is a main package, and that package comes automatically with a Java programming language when you start running your Java program. And object is defined there. So object is the root of all those classes. For example, to explain you this concept, when you load Unix operating system, the first process which is loaded is called init process, and all other processes, login process and so on, other user ID process, all are part of this one now. So the init process is the parent of all the processes. Similarly, the object is the parent of all these classes now. So Java checks during the verification, it checks that whether except object, every class must have some superclass, direct superclass. If object also creates certain superclass, this means certain security violation has been created in the program. Checking that all field references, method references, you will be referring to certain method in your class, you will be referring to certain other fields, have a valid name, valid classes, and a valid type descriptors. Everything is defined into a class. In Java, I told you earlier, and I have been repeating it number of times, that you don't define in C language. I think you can take a liberty, but in Java, everything has to be defined into a class itself. So every variable, every method, every name has to be a part of certain class itself. So this is part. Now what we do is the pass 3 for verification ensures that any given point of the program, no matter what code path is taken to reach that point, the following is true: the operand stack is always same size and contains the same type of value. So the point is here is, which I just try to explain you, the stack is an important data structure in C language, or any important data structure. A stack, queues, linked list, binary tree, they all are important data structures now. And the purpose of a stack is to they provide two types of basic operation, what we'll call them push and pop, and the purpose of a stack is to provide you recursive type of application. So whenever you write a recursive applications, the stack is always there as a main data structure to support this type of activities. So here is to check whether the operand stack, and they try to maintain different type of stacks now. Stacks can be written through hardware, stacks can be written through software. operand stack is always the same size, contains the same type of value. No local variable is accessed unless it is known to contain a value of appropriate type. So these are the important stages which we do at the pass 3 now. And then similarly what we have the class pass 4. Here the ensures that all the reference methods of the field exist in the given class, checks that the reference method or field has the indicator descriptor. So these are the important things which you can understand, but the basic point which we have already conveyed to you, that the purpose of the class loader and the linker is to see that the class files of the program or the file which you are loading it, downloading it to run on your system, follows through all those checks. Now the another important is the term is called resolutions. Now the process of what is the resolutions, the term is the process still is a part of the low level security features in Java programming language. The process of dynamically determining concrete values from symbolic references in the runtime constant pool is known as a resolution. So here is the two types of things that you have to understand. One is called the static and second is called dynamic. So dynamically, most of the Java classes are loaded dynamically on the demand basis. And certain, for example, you look at the scenario which we have to understand, like for example, take example of array. When you declare an array, to understand the word of dynamic, if you have to declare an array, then what we do is you have to define the size of an array. And the size of an array, so memory will be allocated statically by the compiler. In C language or in Java, you can declare a array now. Now array size you have to define. So size of array is basically statically. Size of memory for an array will be done by compiler, and that is called statically. But certain places you don't know that what will be the size of your program. That will be created by the system, by the browser dynamically. So in that case also certain resolution have to be done, and that is done by these units now. You might be referring to certain class or certain other values, not during the static time but during the runtime while you run your programs now. Then in that case this comes into the picture. So basically when we say resolution, it is basically a runtime affair, it's a dynamic environment when you start running your program. So now here is we try to understand these two concepts. One is the static way of handling these issues, and secondly dynamic way of handling these issues now. So statically is a much more, what we say is a much more saving from the memory point of view. You can save your much more memory if you declare now here is, but the dynamically is much more flexible now. That is runtime, as much memory you require you can do it, but it's much more easy to create a statically. So these issues you have to understand, a static and the dynamic thing now. So when it comes to dynamic characteristics of the program, it is done by this type of resolution. Now here will be this type of errors can be thrown by this part: illegal access error, instantiations errors, no such field error, no such method error, if everything goes fine. Now the part is another important concept which is related to the Java security is what we call them the initializations issues now. Now what we do as a part of initialization is the let me just show you some of the definition of what exactly we understand by initialization. The initialization of a class consists of executing these static initializers and the initializers for the static fields declared in the class. So what we are talking about here is that checking it. Suppose that what we do now is that I have defined my program. It contains some classes. It must have some super classes. It must have some the subclasses. Now you look at the second slide, second part of this slide, which message will be much more clear. Before the class is initialized, its direct super class must be initialized. If it not so, then there is a problem in the program. So the purpose of the initialization is that whenever you are trying to access certain data, this relevant data must be initialized. For example, I am trying to use variable x in my program, but x value must be initialized prior to I use this program. So this is purpose of the initialization. If the initialization process has not taken place, if the compiler has not handled this one properly, then there will be a security break, security violations in the program. So right now two stages, you try to understand what we discussed earlier. earlier what we discussed now is that the linker and loader resolve certain issues related to security while loading the class and linking it. The third one, the initialization, is related to when you start running your program, you are referring to certain variables, and if the variables, if certain variables have not been properly defined by other parts of the program where from you are accessing it, then initialization issues deals with this type of security checks now. And here is the basically some examples which we have given to you that you can understand. It's not very difficult now. The another point which I will just explaining to you here is the how we create the what we say the creation of a new class instances now. Just on another example which we have explained to you here. For example, just look at this one way to just with one small example we'll try to explain this concept in much more detail. A new class instance is created when a class instance creation expression is evaluated. And what I'm talking about is that if I try to access any class, it must be instantiated first, right? For example, that is the basic understanding we have. For example, I want to create a stack type of data structure. So I have defined, what I have to do is, first I have to create a stack class, then I have to instantiate a number of objects of these classes. So creating an object or creating an instance of this type of class is almost same thing now. So unless you instantiate any class, you will not able to access to. And if you are trying to access to a particular class which has been not been instantiated, then there will be a problem of instantiations, and that will be a problem of a security violations now. This is what we are trying to experience now. Now here will be again, this is just continuations now. We'll talk about two such models now existing now. That the actual environment which is available in Java is what we say Java JDK 1.1, 1.2, JDK 2. These are the basic models available today to run. These are the runtime environment. They are free of cost available. You can download this environment and run. So to run your program on your system, you must have this type of environment. You must have JDK 1.1, or you can run through browsers now. Now here will be just few examples to explain what are the features of these environments and from security point of view. So JDK 1.1 is one of the oldest, I mean the beginning when Java started, this came. So 1.1, let me just list now some of the important features of security supported through JDK 1.1. Now JDK 1.1, local applications and correctly digitally signed applets were trusted to have full access to vital system resources. Now today what we say the one, I will just explain one or two concepts here which is very much important for you. Today in India, very much back to India, if you look at the scenario that the parliament has passed a legislation where the digital signature has been accepted. Now by digital signature means that suppose that if I have to withdraw a certain amount, then this bank will give you certain code, and if you refer to that code for the transaction, the amount might be delivered to you. This is called digital signature. It has been passed by the parliament, still not fully operational, but it very much will be legal document. Today to withdraw your amount you have to sign it on your check. But now if your bank is located somewhere else and now you want to withdraw your amount or transfer this amount to somewhere else, today we do lots of online shopping now. Now with online shopping and the site is somewhere else, the places is somewhere else where from you buy all those things. By digital signature you can do all these transactions provided the government honors those type of signature. Now they have, so if you have got a digital signature, it means you have got certain code and use that code for doing any transactions now. So all those applets which are trustworthy applets has been digitally signed by the person who have created or the person who have direct access to it. So this is basically, so they support digitally signed applet. This is the important component. And if applets are not trusted and could access only limited resources, for example, if the applet had not been signed, they cannot access to all the resources. But if applets are signed, digitally signed, then it can access to all those resources. Now, for example, I can download certain applet from somewhere else. If the applet wants to have a local resources, if it is digitally signed, then it can access to resources like local network, local C files, local databases, But if those applets are not digitally signed, then it has to go back to the places where from it has come. It will access their resources, do some work, and then finally produce the result. So you try to understand what we are talking about. So JDK 1.1 is an environment to run the Java program. If you have this JDK 1.1, they provide two types of feature: digitally signed applets and undigitally signed applets. If digitally signed applets, then JDK 1.1 gives it more flexibility to access the local resources. If it is unsigned, then they will not have such flexibility. Again, they will go back to where from they have come, access those resources there, and then give you the final output now. And then there are the provision of security managers now. Now, normal programming language, you don't have own security manager. Suppose that I want to, this file should not be accessed, or more comprehensive policy I want to support for my program. It is not possible now. But here JDK 1.1 security manager is possible. You can install security manager in your program and make it much more secure. So this is possible now. Now look at this scenario now. This is the another scenario we have. JDK 1.2 security models are there. Java virtual machines are there. You can provide security policies. You can download, look at on the top, I can download a code from the local or the remote code. I can provide security policies here, right? And the class loader will accordingly act according to the security policies, and I start running on my system called Java virtual machine. These are the various resources are there, and there are different access mechanisms, what we call them sandbox model. This is one of the earliest model which we supported now. So what we are trying to do is that the means if you don't have access, if you don't have sign, if you don't carry digital signature, you will not able to access local resources. This is where they have a different type of models are there. And they can grant you different type of permission. Like for example, permission represents access to a system resource. You can access a database, you can access a local resource in terms of C program, you can access to your network resources and so on. Right? So the code attempting to access a resource must be granted the permission explicitly if it has been digitally signed. Anyway, with this, I will just let me summarize what we have discussed. Here is the purpose of this talk. Today's talk was to give you some insight into the security features of a Java programming language. And we talked about the last part of my presentation was simply to introduce you JDK 1.1 and JDK 1.2 environment, which have certain security features like digitally signed applets, which will have a lots of flexibility in accessing the resources than not signed applet, which does not have much access to the resources now. And the first part of my presentation was related to low level security, which is enforced by the class loader or the linker, which does lots of verification process, and we explained you 3 or 4 steps what we go about it. The last part, just let me summarize you that Java is much more secure than other programming language, because Java's environment is distributed environment, where in other programming language the environment is restricted to a single machine. So security is not a big issue in other programming language, where in Java, yes, we have, because Java assumes that all machines are connected through internet. And internet is very vulnerable system. People have these public systems, anybody can have access to it. They can put certain code there and they can do anything there. So Java has to provide this security. So we talked about various features at low level and at the high level in Java. This is all we had. Thank you.